Well, this is second over the ground.
Get onto orbit, and the first thing we have to do is to open up the payload bay doors so that we can start cooling all of the electronics inside the orbiter. The doors are actually opening at a faster speed here, shown at a faster speed than what we actually open them at. It also gave us our first really nice view of Unity in the back of the payload bay.
On the second day of the flight, we went ahead and checked out the shuttle's robotic arm to make sure it was operating fully, and the shuttle's robotic arm worked just great. It flew identically to the way that our simulators fly. These are the snares closing. That's the manner in which we grappled Zarya, was through closing those snares onto the grapple fixture that was mounted to Zarya. And then on flight day 3, it was time to extract Unity from the payload bay. It was wedged in there pretty good. We had a fairly limited clearance to bring it out of the bay, so the whole operation took about an hour and a half to maneuver it up and then onto the orbiter docking system that you saw on the forward portion of the payload bay. And we just flew the arm very slowly, and Jim was great help being my assistant and letting me know how quickly we were moving the payload. We then pitched it up about 90 degrees, rotated it around to align it properly with the orbiter docking system. And the unique thing about mating these components is we actually didn't use the arm to bring it all the way down onto the orbiter docking system. We took it so it was 6 inches apart, and then we fired the thrusters on board the shuttle to provide the closure rate necessary to attain the capture sequence, and you saw the thrusters firing there.
Nancy did an outstanding job pulling the payload out of the payload bay, Unity. Couldn't have done it better. Very smooth and controlled and precise. She had less than an inch of clearance on either side as she brought it up. She was pretty happy when everything turned out right. And here you see the final closure of the Zarya with the orbiter docking station, just like we dock with Mir Space Station. Once pulled together, we have a solid mating surface. We drive the hooks and can pressurize it so we can go inside.
We had a lot of EVA equipment that was stowed in the middeck of the orbiter, and every time we had spare time, we would go down and start to prepare that equipment for going outside on our 3 spacewalks.
The rendezvous was absolutely fantastic. To see Zarya, which means sunrise in Russian, out on the horizon as we closed in on it for our capture. What a beautiful sight. Rendezvous is a real team effort. You can see us working on the flight deck here as we approach Zarya from 600 feet underneath it. Everybody's taking pictures. There's Jim using the handheld laser to get an accurate distance from it along with our other tools. Rick has moved up into the commander's seat, and I'm moving back to the aft flight deck to fly Endeavour as we come up to 600 feet and then move 350 feet out in front of Zarya, and then come up 250 feet above it and fly it right down in the payload bay. We were using cameras for positioning. Here you can see it approaching its movement down in the payload bay, actually disappearing behind the node as it gets in closer. And here's a computer view of our profile as we flew it in.
We use the laptop computers to help us better understand orbital mechanics because it's not always intuitive.
The final grapple and proximity operations were done at night. You could see it starting to get darker there, but the orbiter payload bays and the cameras we have allow us to light it up so that we can see it well. We ended up bringing it down in the payload bay and then station keeping on it for what Nancy and I call the longest 17 minutes of our life, having Zarya about 2.5 to 3 feet from the end effector and keeping it still there.
This is a view from the end of the robotic arm and the camera located on it, and this view is now actually from the Russian module Zarya looking down on the arm as it comes into grapple. We actually didn't have that view in the cockpit, and so it was quite a unique experience to know that the ground was looking over our shoulder literally as we came in for the grapple. So we brought it down right over that grapple fixture, that long pin, and closed the snares that you saw in the earlier version to attain the grapple and rigidization process required to maneuver Zarya around. We were very, very happy after we grappled this 45,000-pound free flyer after Bob had literally flown formation with it at Mach 25. And then it was time to install Zarya on top of Unity. Again, we were operating almost at the limit of the robotic arm because the Unity module extended about 40 feet out of the payload bay, and so the arm was almost fully extended as we brought Zarya up and over Unity into the install position. We actually couldn't see the mating surface where it was going to mate, so we had to use cameras alone. This is the elbow camera view. And again, we fired the thrusters to attain that capture sequence with the androgynous positioning mechanism.
Just a really nice view of the space station docked to Endeavour out the overhead window. And now it's time to go to work and start the spacewalks.
Here you see Rick and Sergey as they're opening up the hatch that goes from the mid-deck or living volume of the space shuttle back into a tunnel that leads to the airlock where our spacesuits were stowed and what we use to go in and out of the space shuttle on our 3 spacewalks. Here we are in the mid-deck, Jim on the right and myself on the left, as we're demonstrating in space that you can put both your legs into your pants at the same time in zero gravity. After I got my pants on, I went into the airlock to start getting into the rest of the suit, and here's Jim finishing his suit up and going back through the tunnel to the airlock to get into the upper half of his spacesuit. You might notice there's a lot of tools and equipment stowed in that tunnel. There were more that were put in there after we got into our suits, and we used that volume very much to our advantage to transfer a lot of equipment outside to be added to the external surfaces of the station. Jim now into the upper half of his suit, he's putting on his Snoopy cap, his comm cap. We had to put on our gloves, button up our waist bearing, and put our helmets on, and then go through a check out of the suits and a pre-breathe to make sure that we didn't have any problems with the bends. And then when that was all completed, it was time to go outside and start our task.
Here's the cracking of the egg as Jerry opens up the thermal cover and begins the first spacewalk.
We went right to work. We had one crew member that was normally working on the end of the arm and a foot restraint that we had attached there. And the other crew member normally did most of his work in a free float manner, holding on to the sides of the orbiter and space station as he did his work. Nancy operated the mechanical arm for the first 2 spacewalks, and Bob operated on the third one. The arm gives us a very good work platform. It gives us opportunity to have our feet anchored in a foot restraint, and therefore leaves both of our hands free to do the types of assembly work that we were doing. The most important part of the first spacewalk was the connection of 40 different electrical connectors that allowed all the communications and control signals to be transferred between the various different elements of the station, and also, importantly, the electrical power to be transferred from Zarya down to the Unity module so that we could start to activate all the systems inside the US-built Unity module.
Here you can see the power tool that we used to loosen a lot of the bolts that were holding down the cables for launch.
Jim normally was responsible for removing those cables, both the bolts and clamps that held the cables in place, and then he would hand those off to me, and I would make most of the electrical connectors. He also made some of them. And you can see we're working at the orbiter end of the node there, finishing up the electrical connectors there. We then strung a slide wire, which was something that allowed us to transport ourselves up and down the side of the node very efficiently. Then we went to work at the top of the node to remove the cables at that end from their launch positions and to connect those for their on-orbit use. You can see Jim here translating up the slide of the node using the slide wire that we had just installed, and you can see he's carrying a foot restraint with him that he used for some of the tasks up at the other end of the station.
This shows how useful the body restraint tether is. It's a way of carrying equipment around or of attaching myself to a handrail so that I can have a more stable area to work and can free up my hands to work if I need to.
Here I am again up at the top end of the node, finishing up the connections of the electrical connectors from the PMA, and here are Jim and I now up removing the cables from the Russian-built hardware, Zarya, and transferring them across to the PMA-1 U.S. hardware and allowing electrical power to flow into the U.S. half of the station. Since we were ahead of our timeline, we continued on with tasks that were planned for our next spacewalk, and here we are transferring some equipment so that we can each go or do our own task. We were installing some handrails and some additional foot restraint sockets that were used on subsequent spacewalks.
After the completion of the first spacewalk, we then activated the space station from inside and actually turned on the computers and electrical power to it, and what a great moment that was. After that, we boosted the space station to a higher altitude using the +X RCS jets on the orbiter. Each one of those jets gives about 800 pounds of thrust, and through a firing sequence that required a lot of analysis so we didn't break the space station. You can see it oscillating back and forth here after one of the firings. We boosted it approximately 8 nautical miles with 11 firings. A little oscillation in one of the solar arrays there. It was 2 minutes and 10 seconds between firings, and that all damped out before we did the next one.
Okay, on the second spacewalk, it was my turn to go outside first to get on the arm, and our primary task on that day was the early communication system. What we were doing is bringing up a communication system that would allow Houston to have video teleconferencing and command and data to the fledgling space station. Although the Russian side is prime for communications early on, they are restricted to communications during their ground passes, and that leaves a lot of the orbit with no communications to the station. And here we are transferring some of that equipment, those antennas, using the arm and the body restraint tether. You can see here that with an orbit that goes around the Earth every hour and a half, that there's 45 minutes a day, 45 minutes of dark, and during the dark times we keep working using our helmet lights. Here we are up at the Zarya Unity interface, and from there I transferred with a boat hook. There are antennas that the Russians had expected to have deployed, but which did not employ, one on each side. So Jerry and I, each on 2 different spacewalks, took this boat hook and encouraged the antennas to deploy. It turns out they just needed a little nudge, and after doing that, and allowing a little bit of time, perhaps in this case, to warm up, and don't blink here, because what we'll have in a moment will show you what the antenna itself looks like, and then we'll show a picture of the deployment itself. The antenna is a coiled metal on a spool, and there goes the spool. So with activating and deploying that antenna, now the Russian Toru system, which is a manual backup to their docking capability, would be fully operational.
Jim turned real quick there and said, "Where'd it go?"
I did blink and missed it, and I made a quick turn to try to see where it went. On the next one, which Jerry will tell you about on the last EVA, I didn't blink. This was a shot of the end of that final spacewalk as we were cleaning up the payload bay.
At this point of the flight,
before the third EVA.
One of the primary tasks of this spacewalk was to add a very large bag about 3 feet on a side to the outside of the station, which contains a lot of tools which will be used by future crews in the assembly processes of the station. After that was done, then Jim and I came back down to the orbiter end of the space station and disconnected 6 cables and stowed them. Those cables are no longer needed, and to get ahead for future assembly tasks, we removed those cables and stowed them.
It was very symbolic. It really represented the permanent joining of our 2 countries in this space endeavor.
Then the second of the 2 Toru antennas that had not deployed properly were attended to, and you can see me on the foot restraint here using the boat hook or pole to release that second antenna, and there it goes. The spool missing the tail of the orbiter by quite a few feet. We then proceeded all the way to the top of the Zarya stack, about 80 feet out of the payload bay of the orbiter. We installed a handrail up there at the top of Zarya, and then also identified 2 exposure trays that were no longer in their proper on-orbit configuration. They probably vibrated free during launch.
You have to look very carefully to see us up at the very top of that stack, 2 small figures working.
After we were given go from the ground to fix those 2 trays, we did that, and then we proceeded back down Zarya, back down onto the node. We finished off our operations on the stack of the station, and then had the opportunity to do a flight test of the rescue backpack, the little rocket rack backpack on the back of my suit. We identified a couple of problems that we're going to fix, and we'll have a fully functional, satisfactory way for a crew member to save themselves should they become detached from the structure of the station.
Sure was a pretty sight, seeing the space station attached to Endeavour, but then came the point in the mission where we had to separate and prepare to come home.
And this next sequence of shots again highlights all the teamwork on this crew that really went into almost every event. There were at least 2 of us, and you'll be able to see here as we separate right there from PMA-2 from the orbiter docking system and begin to back away. When we get to 2 feet, then I'll put in some out pulses which will cause Endeavour to fly away from the International Space Station.
Rick was at the flight controls at the aft flight deck for this portion of the mission and flew Endeavour away from the space station out to a distance of 450 feet and then flew around it 1.5 times, and he did an outstanding job.
We undocked in darkness, but very quickly the sun rose, and this shows everybody. There's Nancy at the front inputting the orbiter attitudes into the Space Shuttle computer system. There's Jerry is closing out the docking system, performing the final steps to secure that. And Jim was assisting with the computers and taking handheld laser marks. As the sun came up, it was very bright in the cockpit, and fortunately the experienced crew members warned me that it would be necessary to have sunglasses. As we backed away, we just had beautiful views of the space station that we couldn't really see as well when we were right docked with it, but it was just a beautiful sight against the background of the Earth there. And you can see Sergei is beginning the photo documentation. We flew around 1.5 times so that the station could be documented from all sides with different lighting. And those photos will be analyzed by the folks on the ground and used to train future crews as well.
What a fantastic view. What a sense of accomplishment to see an operating International Space Station on orbit.